Hello students, let us take a problem on collisions and center of mass chapter which is asked in 2024 IIT-JEE mains. It not only linked with collision chapter and also from the rotational motion chapter. So let us have the question. The question as follows. A uniform rod AB of mass 2 kilograms and length 30 centimeters at rest on a smooth horizontal surface. It is at rest on a smooth horizontal surface. So an impulse force of 0.2 newtons is applied to end B. The time taken by the rod to turn through right angles will be. So you need to understand the question actually here. So before going to the question, as the problem related to the impulse, so impulse in the sense it is a change in the linear momentum. So change in the linear momentum will be is equal to force multiplied by time interval. Similarly, change in the angular momentum will be equal to torque multiplied by time interval. Okay. So these two relations are helpful to solve this problem. So here linear momentum in the sense it is P is equal to mass into velocity. So angular momentum obviously L will be in this problem. Of course I omega. I is the moment of inertia and omega is the angular speed. The situation I will explain first. So there is a rod which is at rest. So this end is A and this end is B, which is at rest. Now an impulsive force is act here. That means a force of 0.2 newtons acts suddenly at that particular point. So take this will be the center of mass of the rod. So due to this force, the rod translates as well as rotates. It's not only translates but also rotates. So that means just immediately after this, the situation something like this. The center of mass will be even translating as well as it is rotating. The rod is rotating with an angular velocity omega. Okay, so after how much time the rod will be rotated by 90 degrees. So it translates, even rotates. After some time the scenario will be something like this. Even it translates as well as rotates. It will be turning 90 degrees. It will be turning right. So vertical rod will become horizontal, turning in the sense. It is the situation. So this is the point A and this is the point B. Okay, translates as well as rotates. So how much time it takes to transfer from this state to this state? This time interval, this time I need to calculate here. Okay, so the idea is very simple. If I know the omega value here, so then by using theta is equal to omega t formula I can calculate it. So theta here 90 degrees, as it turns 90 degrees, that is pi by 2 is equal to omega into t. So from here t will be is equal to pi by 2 omega. The thing is omega I need to calculate here. How I will calculate the omega here? Simply I can apply the angular momentum. So final angular momentum minus initial angular momentum will be is equal to torque into dt. So final angular momentum I can write moment of inertia about the center of mass into omega. Initially the system is at rest, that's why it will be 0. Torque means force multiplied by perpendicular distance. That force will be I am writing as it is already given. Force multiplied by the perpendicular distance. Perpendicular distance from here to here it will be the L by 2. If L is the length, L by 2. So into delta t. Okay. So from this, moment of inertia of the rod is comes out to be ml square by 12 into omega will be is equal to L by 2 into F into delta t. F into delta t. So it is mentioned that impulsive force of 0.2 2 Newton second is applied. That means given that F into delta T value is equal to 0.2 Newton second. So with that L by 2 cancel, M into L omega by 6 will be is equal to, that is F into delta T, its value is 0.2. From here omega comes out to be 6 into 0.2 divided by mass multiplied by length. Mass is given as 2 kg, length is given as 30 centimeters, in the sense 0.3. So that is 2 into 0.3. Correct? So with this, what is the answer I'll get here? 6 into 2 divided by 2 into 3. So answer comes out to be 2 radians per second. Right? So if I substitute here in my time relation, t is equal to pi by, so 2 into 2 comes out to be 4, then x value comes out to be 4. Okay? Clear, I think. So remember the ideas that I have used to solve the problem. So you have to remember these two relations related to the impulse. One is linear impulse, another one will be angular impulse.